I came across twin paradox, which is very common paradox, especially discussed when relativity is questioned. The reason the question comes is it's not about like time dilation. Yeah, you understand like time dilation, and there will be a difference in age. That's it. There is one channel that explains TED and air. So like there are Stella and Terra. So Terra is like kind of considered as stationary frame, and Stella is considered as like moving frame. And so Stella's age will not increase that as much as of Terra's. But what if Terra considers herself as moving and Stella as stationary? Then what will happen? Will Stella age more and Terra will not age that much? So that is the basic idea. And but unfortunately, people are like entering talking about acceleration and all sorts of things. And that kills the basic question, the why paradox is there. Same way I found like there's another Sabine, and she's very like influencer, YouTube influencer, around like 1.59 million subscriber, and like no, she's like explaining the same thing like acceleration. There is not point of acceleration. How much time will it take to accelerate in space? 1 month to reach speed of light? It's a thought experiment. You can just like that go at speed of light. But if you think that it's like mathematical problem and try to solve this thing as a kind of like quiz, then you are like killing the basic concept, the idea behind this paradox, why it is there. It is challenging the relativity, the concept. The one frame is stationary and other is moving, then what will it be? Effects. If Einstein was right, and this is challenging, guys. It is not a mathematical puzzle the way they are trying to explain. And I came across Fermilab, and the gentleman rightly says that, and it's a really good explanation he tried to give. And he pointed out outright that the central issues is that everyone can say that they are moving. And so if everyone can say that they are moving, then everybody's clock will be slow with respect to another. So there is no point of acceleration, deceleration. That's exactly what he pointed out. But it seems that most people are watching videos. And if you are looking about like twin paradox and you came across a video which is talking about acceleration and deceleration and whatnot, then probably you will believe that, because you have no fundamental concept of what relativity is and why whole thing is. So you just believe because you want to learn, but your teacher is not giving you correct information. And I watched the Fermilab's video, and it is really interesting. And he said that in his example there are two, Ron and Dawn, and these two twins have this long journey. One is on Earth, another takes journey, and this mathematics something it will take 8 years and 4 months. Like these details, like not important. The concept is that what we have to understand, that the one who is considered as moving ages less. But the question is like, who will be aging less and who will age more if both can claim that they are moving? And that is the basic challenge to the relativity. And the whole twin paradox is not at all about acceleration, deceleration, or going here and there, or it is all about relativity. So unless you know what Einstein suggested as relativity, you even don't understand the question. And then you try to find answers, and then you actually believe all those answers. And here in Fermilab, the gentleman very rightly tried to explain. And what he did is very nice. And he, instead of having two frames, now two person like Ron and Dawn, there are only two frames. He introduced another one more frame. Then he said, let's say A, B, and C. And there are some 3 locations, and he has his own illustration and like the idea. But like it is real good. But one thing I noticed, and that he said, when we start out in his illustration, he points out, when we start out, we put ourselves in the point of view of observer A. Observer A just sits unmoving at location 1. So that's what he says, that A is sitting just like that, as if like absolutely stationary, or just like a stationary reference. Like probably it will be hard for you to follow what I am saying. But anyway, so A kind of becomes a reference, and then B and C both are moving. and then he tried to explain why relativity and who will age or whatever, and he explains. But that's kind of like going about to explain relativity as it is. It is not actually addressing the paradox, the relativity between two frames, which one is actually moving, and that's like still unknown. And rightly I tell you that it is impossible to find out which one is moving and which is not. That's exactly what relativity, and that is the paradox. But I found that people like actually do not understand, and then they'd like to argue. But here, this gentleman, like no, in dialect philosophy, I think that is the name of the channel, and he said like no, he went to many, and in his video he had put many such videos like explaining twin paradox, and he said like all the solutions of the twin paradox still are wrong, and he is right, because the idea behind whole twin paradox is having only two frames and find out which one is moving and which one is not, and that whole thing is. But like I will bring your attention back to the Fermi lab, where he had like introduced like third frame. There is only two frame, B and C, Ron and Don, but he introduced another frame, some stationary viewer who is observing Ron and Don or something like that. So there are three frames. So then he tried to answer, and this reminds me what happens with Einstein. And Einstein, when he was quizzed about Michelson-Morley experiment, then this is what had happened, and I will read it from a book, and it will be easier for you to follow because I'll put it on the screen also. And here it is on the screen. In Michelson-Morley experiment, a light beam was split into two to detect the presence of luminiferous ether, that is in 1887. But no difference in speed of light was detected regardless of direction. And this challenged the then prevailing scientific theory. Now let us understand that it was a scientific theory that they were believing in ether in 19th century. So even the scientists were believing. So like if you consider scientists as like authority which can never be refuted, then you have to reconsider that concept. And in 21st century, we believe certain things which may be proven wrong later on. So we have to be ready for that. And here, well, anyway, and later, Einstein's theory of relativity proposed time dilation and length contraction in moving frames. But the Michelson-Morley experiment and its repetitions, which much higher accuracy, didn't detect any length contraction. Einstein addressed this inconsistency by stating, thus for a coordinate system moving with the Earth, the mirror system of Michelson and Morley is not shortened, but it is shortened for a coordinate system which is at rest relative to the Sun. So now this is crazy thing, because there is only two frames were there, because like if we consider there were only two things which were moving. One was light itself, and second is the Earth or the Michelson and Morley experiment apparatus. Only there are two frames, and yet Einstein introduced third frame as Sun, just like we see in Fermilab's video. In his explanation, he introduced one more frame, A, which is stationary. And then he tried to explain B and like motion of B and C. But well, relativity is between two frames and not three. It was not in the picture, and yet Einstein brought it. And if you think like carefully, like maybe one day you will think that, and you will understand that when Einstein was in 1905, he presented his relativity, and science was emerging from that idea of ether, and they want to do away with this thing. And so they just rejected space or absolute stationary frame of reference, or maybe like even moving. If you consider space as moving frame, that's also okay, but there is some frame which is a common for everybody, all the objects or all other frames. So they were rejecting it. So Einstein introduced a frame with reference to Sun. Earlier, like if you take like geocentrism, it's a new way of like heliocentrism. But that's like a different story. What I wanted to tell you is that Einstein introduced a third frame, and then he also said that every ray of light moves, and that is in his book. He said that every ray of light moves in the stationary coordinate system with the same velocity c, the velocity being independent of the condition whether this ray of light is emitted by a body at rest or in motion. In short, he's saying velocity of light is independent of the velocity of the source. And so he actually, like as I said, pointed out that he introduced like another third frame, and Michelson-Morley experiment has only 2 frames. And so same way, like if we look back to the illustration given by Fermilab, and then where he says that there is another frame he just introduced by himself, and he said like it's just stationary, and there was only 2 people, like A, Ron and Don, but then he introduced some another frame, A, B, and C, and so that's how he explained. But then it is not addressing the basic concept of basic question raised by twin paradox. Now let's take instead of twin paradox, let's have a triplex paradox. And what is triplex paradox? Let's say there are 3 things: Ina, Mina, and Dika, and these 2 are in the space in different spaceships, but they are stationary to one another. So Ina and Mina and Dika. So this Mina and Dika wants to go away, far away. Maybe they go towards the Andromeda galaxy or somewhere, or just like in the space there is nothing else, just they go out on a journey, long journey at the very higher speed, near speed of light, and they go away. But interesting thing is, Mina says, I am stationary. He thinks that he is stationary, and Ina is moving away. Contrary to that, Dika says, I am moving and Ina is stationary. So now here in the same one spaceship, there are 2 observers. One is considering himself as stationary, and second observer consider himself as moving. Now if they go all the way and then they come back, now who will age more in this case? Like they are traveling in the same ship, and that's the triplex contradiction, or I say like triplex paradox. That's that's the correct word. It's a paradox. It was earlier, it was 2 twin, like no, one goes away and one is here, but like 2 observers traveling the same ship. They go away, far away, and then they come back. Which one of them will age? The one who consider himself stationary, or the one who consider himself as moving? But remember, they are in the same ship. They go and come back. So what will happen? So let me know in your comment, and maybe you can ask your friends, family, relative, professors, someone, or the other people who are making video, and try to find out what will happen in this triplex paradox. Well, thank you for watching. Keep watching and have a nice day.